And here we have what might be our first big moment of satisfaction. Let's create the parametric curve. Now the format in Desmos for creating parametric curves is parentheses. I'll put big X of t, comma, and then big Y of t. I'll change the interval of t to go from 0 to 21. I'll hide the individual pieces. And check that out! I feel bad for non-math nerds who will never understand the thrill of seeing the design successfully appear on the screen like that as a single curve. We've thus far only been focusing on one half of the design. Let's think about how we can get the other half with very little extra work. Let's bring back our individual curves from way back in step 1. On those curves, we have points x equals 22, y equals 0. X equals negative 22, y equals 0. X equals 2, y equals 17. X equals negative 2, y equals 17. X equals 12, y equals 14. X equals negative 12, y equals 14. What I'm getting at is we want to duplicate the mirror image of the parametric curves that we've already made, but in that mirror image we want opposite signs for the x values and same signs for the y values. So let's look at those components individually, and let's look at the y of t graph first. We're going to use a technique that I mentioned way back in step 1. Let's define y2 of t to equal y of t, but let's replace that input variable, t in this case, with absolute value of t, and I'll hide the original y of t. Remember how that keeps the original but reflects it across the vertical axis? This is exactly what we want. Notice that all the duplicate y values have the same sign. 5, positive 10, negative 5, positive 10, 3, positive 17, negative 3, positive 17. That's what we wanted for the y values, same sign. Let's go to x of t and start by doing the same thing. I'll do x2 of t equals x of t, but I'll replace the input t with absolute value of t. Let me turn off the y2. Now that's a start, but that's not quite what we wanted. We wanted the x's to have opposite signs. So when t equals 13 and x equals 22, I wanted to have t equals negative 13 and x equals negative 22. I want all those duplicate values to have the opposite sign. So let's do that by multiplying this x of t. Let's put this in front. Absolute value of t over t. And there it is. 13, 22, negative 13, negative 22. The graph now has odd symmetry instead of even symmetry. You see why that works? You see how that multiplier has a value of negative 1 whenever t is negative, but it has a value of positive 1 whenever t is positive? I hope that's clear. Okay, we've addressed symmetry on the x of t and y of t components individually. Let's now look at the parametric curve. Let's go back to our parametric curve, x comma y, and let's change those. Let's change those to x2 and y2. And let's change the interval to go from negative 21 to 21. And check it out, there it is, our new complete Batman curve, expressed entirely as a single parametric curve here in Desmos. It could have just as easily been done in Geogebra and probably a number of other graphing software packages. Recall that one of my gripes about the original 2011 Batman equation is that it couldn't really be graphed as a single curve in most graphing software. It had to be graphed as 6 or more individual curves. Admire that in this case we've achieved this. It's graphed as a single curve. Now if one wants, instead of doing the x2 and y2, you could have just gone to the original x of t equation, and you could have just replaced all those t's in the input, every single one of them, with an absolute value of t. You could have done the same thing with the y of t, replaced all those t's with the absolute value of t. Remember, with the x of t, you also need that multiplier in front. We need that absolute value of t over t in front of everything else contained inside parentheses. And if you really wanted to make this one line totally independent of all the other lines, you could then even copy and paste the x of t line and the y of t line. You could copy and paste them right here into this line and have just one single line all by itself. I'm not going to do that right here. I'll assume you'll choose to do so if you feel like it. Instead, I'll simply show you that here is our updated parametric pair with all those mirror images implemented. Notice how each of the t's in the inputs have been replaced with the absolute value of t, and we have our multiplier there as well.